Welcome to all. In this session, we are going to discuss about the priority scheduling algorithm with the preemption. So we already discussed about the what is preemption and then non-preemption in the shortest job first. The same thing will be applicable for the priority scheduling also. So for the priority scheduling algorithm, so always the CPUs are going to be execute their process and they based on the priority. So here the based on the preemption means obviously all the process we will be giving the arrival time. So all the process are arriving at the different timing. So when the overall the process arrived in the ready queue, so first we are just comparing their priority. So which priority is currently running? So the upcoming the priority is lesser than, that is a higher priority means, so the currently running process is going to be preemptive process, and then chance is given to the newly arrived process. If it is a non-preemption means, so the current running process simply it is running, it will complete the process, then only it is given to the next process. That is the difference between the preemptive priority and then non-preemptive priority. The same how the shortest job first preemptive and non-preemptive is working similar way, but in the shortest job first we are just considering the burst time. Here we are just considering the priority. Fine. So the same example we will just taking, but the arrival time now I am just mentioning. So the arrival time for the P1 is 0, I'm just taking, and then arrival time for the P5 is 1, and then arrival time for P2 is 3, and then arrival time for P3 is 4, and then arrival time for the P4 is 5. Now you just consider like this. So now if you are just making the Gantt chart, so now all the process arriving at different time. At the time of 0, only one process is there, that is P1. So the P1 will start its work. So it is executing and complete its task in 1 millisecond. At the time of T1, P5 was arrived. So now the condition we have to check the priority of the P1 and then P5. So which one is the highest priority? So again we are just taking the 1 is the highest priority as of our condition. So the 2 is the highest priority. So the P1 is going to be preempt its process. Now the hand over the CPU to the P5. So P5 will start executing. So the P1 burst time is 10. Already it is completing 1 millisecond. So the remaining time burst time is for P1 is 9. So now P2 will start executing. Now the time is 2. At the time of 2, no other processes arrived. 0, 1, 3, 4, 5 only. At the time of 2, no other processes arrived. So again the P5 is continuing. So now the time is 3. Okay, so the 2 millisecond was P5 was worked, so remaining is 3. At the time of 3, we are checking the priority of P2 process. So P2 was arrived at the time of 3, we are checking the priority. The current execution process priority is 2, and then upcoming the process, the P2 priority is 1. So obviously we have to hold on the P5 and giving the chances to the P2. So now the P2 start executing, its burst time is 1. So it is completing within 1 minute. So the time of 4. No issues. Now P4 is coming. So the P4 in the arrival time, the priority is 4. So already in the ready queue, so we have the 3 process. So now the P2 was completed stage. So the P1 was arrived. It's in a waiting stage. And then now only P3 is arriving. P5 is in the ready queue, it is a waiting stage. So now the P3 was arrived. So it is also in a ready queue. Now we need to compare all these three things priority. So P5, so remaining time is 3, its priority is 2, and then P1 is already is there in a waiting queue, in the ready queue, so that is a burst time is 9, its priority is 3, and newly arrived process is P3, its priority is 4. So now the P5 will start executing because its priority is less. So start will execute, and 1 millisecond at the time of P5, at the time of 5, again one more process is coming. So I'll just make the ready queue here, then you can easily understand who are all in a waiting for the execution, the ready queue already. So P1 is in a ready queue, again the P5 is in a ready queue, this is ready queue, so hold on, P2 completed. Now again the P3 was arrived with the priority of 4, so with the priority is 3, and then priority is 2, and then P3 priority is 4. Okay, so P3 is compared with the P5, so P5 is start executing. After 1 millisecond, again one more process is arriving, P4, with the priority is 5. These are all priority. Okay, so now again we are comparing, P5 is running, P4 is newly arrived process, we are just comparing the priority. So P5 is the highest, so we are not leaving, the P5 is not preempting, it is going to continue its process. So how much time it's remaining? So already is a 3 balance, so 1 millisecond is, so it is going to be complete its process at the time of 5, 6, 7. Okay, so then P5 is completed its process. All the process now it's arrived. So now in the ready queue, according to the priority, now one by one it is going to be executed. So highest priority is P1. So again P1 will start. So what is the amount of the remaining burst time? So 9 millisecond. So 7 plus 9, 16. So P1 complete. Then P3. P3 burst time is 2. So 18. P3 completed. And P5 burst time is, sorry, P4 burst time is 19. Okay, so like that the preemptive priority will work on. So now we need to calculate the waiting time. So here we need to calculate carefully because all the process arrived at different time. Okay, so P1 waiting time. So how the preemptive shortest job first we calculated the waiting time, the same thing. So when it is getting the chances, when it was arrived, and similarly what is the working duration period. All these three things we have to take care. So P1 was arrived at the time of 0, it's getting the chances here. Again it is hold on, then next chance it is getting at the time of 7. So only this period is the waiting time for the P1. So waiting time for the P1 is 7 minus 1, 6. P2 was arrived time is 3. It is getting the chance at the time of 3. So 3 minus 3. So waiting time is 0. P3 arrived at 4. But it is getting the chance at the time of 16. So 16 minus 4. So 12. P4 arrived time is 5. P4 getting a chance at 18. So 18 minus 5. And then P5 arrival time is 1. It is getting a chance at 1, but it is not completed its process. again at the time of 7 only it is completed. So this period is the waiting time for the P5. When it is completed, we need to check. Arrival time is 1, so here it is not waiting time, directly we just start working. But after some time it is waited. So this period, so 3 to 4, that 1 millisecond is waiting. So this is a waiting time for the PI. So now we can calculate the average waiting time. As usual, you just add it all and then divide by 5. So that is the average waiting time. So similarly, we need to calculate for the completion time. So what is the problem in the priority scheduling algorithm in the sense? So the major problem, always the process are working based on their priority. So sometimes, so the low priority process always in the waiting stage. So sometimes it may be a block. So this is called as indefinite blocking or starvation stage. So how we can avoid this kind of the problem in the sense? So based on the concept of aging. So how the age is going to be increased for us? Yearly we are just getting one age increased, right? Similarly, we can fix it for the low priority process. We are just increasing their priority. For example, every 15 minutes I'm just going to increasing the priority, that is a lower priorities. I'm just setting the increasing the one priority. So for example, any one process, if I'm just assigning the priority is a 127 minutes, it's a very low. So every 15 minutes that priority is going to be increased. First it start at the time of 9. So 9:15, its priority is going to increase as a 126. At 9:30, so its priority is going to increase as a 125. So like that the priority is going to be increasing for the every 15 minutes. So like that we can set, so that at least we can avoid the starvation in a minimum manner. So this is one of the solution we are just providing for the avoiding the problem of starvation in the priority scheduling algorithm. Thank you.